Okay, the material we're going to present in this video is a continuation on the stuff covered in a previous video. So in that video we did example number 1, where we were given an equation of a circle and then we found the center and the radius and then made a sketch. In number 2 we're going to look at the reverse question. So this time we want to find the equation of a circle. We're going to be given some conditions that the circle satisfies, and we'll leave the equation in general form. So we've got a few circles here. We are going to do A to E, and then we're going to give you F and G to as an exercise. Alright, so in A we've got a circle centered at 0, 0 with radius 5. Perhaps before we continue with this, let's just remind ourselves that for a circle centered at HK with radius R, the equation in standard form is x minus h squared plus y minus k squared is equals to r squared. So in the first example we have the center at 0, 0 and the radius is 5. So if we simply plug these in there, we're going to have x minus 0 squared plus y minus 0 is equals to 5 squared. So this is simply going to be x squared plus y squared is equals to 25. Then in B, again the circle is now centered at 4, negative 2. The radius is square root 7. So 4, negative 2, radius is square root 7. So again we're simply going to just plug in that equation. So we're going to have x minus 4 squared, y minus negative 2 squared is equal to square root 7 all squared. And then if we open the brackets, it's going to be x squared minus 8x plus 16, y minus negative 2 is the same as y plus 2, going to be plus y squared plus 4y plus 4, and then this side that is going to be 7. So it's going to be x squared plus y squared minus 8x plus 4y. 16 plus 4 is 20 minus 7, so that's going to give us 13. Right, then in C, got a circle going through minus 5 minus, sorry, centered at minus 5 minus 3, going through 1, 4. So the center is minus 5 minus 3. It passes through 1, 4. It does help to make a sketch when the conditions are somewhat more involved. So here I've got center at minus 5 minus 3. It goes through some 0.14. So the thing we need to find is the radius, because h and k, as far as this is concerned, is sorted And in fact, we don't want r, we just want r squared. So that's what we're going to do. So r squared is simply going to be 1 minus -5 all squared, and then 4 minus -3 all squared. This is going to be 6 squared plus 7 squared, 36 plus 49. Well, 36 plus 49 is 85. So we are now in a position to write the equation of this circle. So we're going to have x plus 5 all squared, y plus 3 all squared is equal to 85. Then if we simplify this, it's going to be x squared plus y squared plus 10x plus 6x. We're going to have 25 plus 9 here. So that's going to be 34. And then, of course, we can take the 85 to the left-hand side. All right, so that sorts out C. In D, we are going to, we have, let's remind ourselves, center at 3, 4, tangent to 2x minus y plus 5. Okay, so this circle is centered at 3, 4. It's a tangent to the line 2x minus y plus 5 equal to 0. So again, the simple sketch is going to help us work this out. So there is our tangent there. It's a line 2x minus y plus 5 equal to 0. The center is at 3, 4. Okay, so the thing that we need is the radius here. Of course, that's going to make that at 90 degrees. The easiest way to do this will be to write this equation in normal form, which we've already seen how to do. So a is 2, b is minus 1, so that means square root a squared plus b squared. Gonna go for the negative sign because the constant is positive. So there's going to be 2 squared plus 1 squared, so it's going to be square root 5. Then if we take 3, 4, so let's just write the normal form first. So normal form is going to be 2x minus y plus 5 all divided by negative square root 5. So the radius is going to be given by the value of this side when we plug in 3, 4. So x is 3, and since we're interested in just the magnitude, so we can take the absolute value of this. So it's going to be 2 times 3, that's x minus y is 4 plus 5 all divided by square root that. There's going to be 6 minus 4, which is 2 plus 5. It's going to be 7 over that. And it all becomes positive because we're just interested in the magnitude. So we have the radius, we have h and k. So we can write the equation of the circle. So we're going to have x minus 3 all squared, y minus 4 all squared is equal to 7 over square root 5 all squared. If we simplify this, it's going to give us 5x squared plus 5y squared minus 30x minus 40y plus 76 equal to 0. Make sure you can fill in all those steps that we skipped there. So that is example number D. We're now going to go to E. In E we have got a circle going through these 3 points here. Sorry, this should be -2. So we have got a circle going through those 3 points. Okay. This is how this is going to work out. So in E, we've got a circle that passes through so it passes through 5, 1, 4, 6, and 2, -2. What we're going to do here is we're going to use the general form of the equation of the straight line. You can use the standard form as well. So we're going to start off with the equation x squared plus y squared plus ax plus by plus c equal to 0, where a, b, and c are unknown constants. So then, since the circle goes through these 3 points, it means the equation is going to satisfy each of these 3. So if we start with the first one, so at 5, 1, then this is going to be 5 squared plus 1 squared plus 5x, plus 5a plus b plus c is equal to 0. Just tidy this up. So 5 squared is 25 plus 1, 26. So we're going to call this our equation 1. Then we now plug in the 0.46. Okay, so in that case we're going to have 4 squared plus 6 squared. Let's just sort that out so that we have a so 4 squared plus 6 squared is 52. So we're going to have 52 plus 4a plus 6b plus c equal to 0. So that's our equation 2. Then lastly we've got 2 minus 2. So in this case 2 squared plus 2 squared is just going to be 8. Okay, then plus 2a minus 2b plus c equals to 0. This is equation number 3. So we have got a system of 3 equations, 3 unknowns, which we could solve using different techniques. We could use Cramer's rule. Just going to quickly go through it using the method of elimination. Since we've got plus c here, plus c there, plus c there, then that's going to be easy to eliminate. So if you go 1 minus 2, 1 minus 2 is going to give us a minus 5b. Then here this is going to be negative 26. So if you take it to the right hand side, it becomes positive 26. Then if we do 2 minus 3, so we're going to call this our equation 4. Do 2 minus 3, we're going to get 2a plus 8b. 52 minus 8 is going to be 44. If we take it to the right hand side, it's going to be negative 44. Now I've got two equations, two unknowns. If we multiply 4 by 2, then subtract. Okay, so if we multiply this by 2, we're going to have 2a here and 2a there, and then subtract. So that is going to give us 18b is negative 96, and so b is going to be negative 16 over 3. If you substitute back, you will find that a is negative 2 over 3 and c is negative 52 over 3. So our equation is going to be x squared plus y squared, then a is minus 2/3, b is minus 16 over 3, and then c is minus 52 over 3. We tidy up the fractions. It's going to be 3x squared plus 3y squared minus 2x minus 16y minus 52 is equal to 0. So that is example number E. There's F and G there. I'm going to put example number H, which is somehow I missed. Okay, in this example, we want to find a circle tangent to the straight line 2x minus 3y plus 1 equals to 0 at 1, 1. The point of tangents is given, and the radius is given to be square root 13. So again, little sketch here is going to be helpful. So there is our straight line, and then our circle is tangent to the straight line. The point of tangency is 1, 1, 1, 1 here. All right, so the coordinates of the center we don't know, so HK there. The radius though we do know, so radius is square root 13 here. The equation of the tangent to x minus 3y plus 1 equal to 0. So we have got two unknowns here, if you like, h and k, so we need two equations. One of the equation we can get by writing this in normal form and then plugging in hk, because we know that is 13. So we're going to say the radius is going to be the magnitude of, if we write this in normal form, we're going to have to divide by the square root of 2 squared plus 3 squared, which is 13. Then we're going to plug in h and k minus 3k plus 1. Then this is given to be square root 13. Okay. Then we can remove the absolute values, but when we do remove the absolute values, we end up with two equations. So first we're going to have 2h minus 3k plus 1. I'm just going to take this as square root 13 because well, it doesn't matter anyway whether you take it as negative or positive. So in the first case, this is going to be just square root 13. Then in the other case, we're going to have 2h minus 3k plus 1 over square root 13 equal to negative square root 13. The reason why this is the case is because with absolute values, if ever magnitude of x is equal to a, then it means a is plus or minus, x is plus or minus a. So that means this, when you remove the absolute values, it will be plus or minus square root 13. Just going to work with this one for now. So if we take square root 13 to the other side, so this is now going to be 2h minus 3k plus 1 minus 3k plus 1 is equal to 13. If I take the 1 to the other side, so I've got 2h minus 3k is equal to 12. So let's call this equation 1 for this case. Then we need another equation. It can't be this one because these two equations are basically two cases, and these two cases are because here, with the conditions given, this circle could be this side, but this circle could be this side as well. Okay, so that's why one of them is the plus case and the other one is the minus case. So then we need another equation. So the other equation we can derive from the gradient of this radius there, right? So the gradient of the straight line of the tangent here, so let me call it mt, is going to be 2/3. Okay, which means the gradient of this radius here is going to be the negative reciprocal of that, so it's going to be -3/2. Now, since we know these points, we can write that gradient in terms of h and k. So difference in y is going to be k minus 1. So k minus 1 over h minus 1, that must be equal to -3/2. So if we rearrange this, this is going to be 2k minus 2 is equal to -3h plus 3. And then if we bring everything to the other one side, we're going to have 3h plus 2k is equal to, this is going to be equal to 5. So this is our equation 2 now. Okay. And then if we solve these two equations simultaneously, we are going to get h equal to 3 and k is equal to -2. Then once we know this, so here we've got 3, -2. So we know the radius, we know the coordinates of the center, so we can write the equation of the circle. So we're going to have x minus 3 squared here, y plus 2 all squared is equal to 13. Simplify this, we're going to have x squared plus y squared minus 6x plus 4y minus the 26. All right. Then for this other case, so if you replace this equation 1 by this one here, which means it's going to be -13 in there, and we take 1 to the other side, it's going to be -14. And then if you solve it with that, then you will find the other case, and that equation is going to be x squared plus y squared plus 2x minus 8y plus 4 equal to 0. Alright, so now we're going to give you a few minutes. So if you just pause the video, and then you can have a go at F and G. So just have a go in F and G. Alright, so you have been having a go at F and G. If you haven't, please do pause the video before you look at our solutions. I'm now going to scroll down to our solutions. So for F, we are looking for a circle centered at -5, 6, tangent to the x-axis. So so that means this distance is going to be 5, that distance is going to be 6. If it's tangent to the x-axis, it means the radius is going to be 6. And then of course h and k are 5 and 6, -5 and 6. So we plug this here, and that's going to be our equation. In H, we're looking for a circle whose center is located along the line 2x plus 5y plus 1 equal to 0. So HK is there. Then we know that it goes through 2, 3. So distance from HK to 2, 3 is R, same as the distance from HK to -1, 6. So from this one we can write this equation, and from the other one we can write this other equation here. If we expand this one, we're going to get what we've labeled our equation 1, and if we expand this other one, we're going to get our equation 2. Now notice here we have got 3 unknowns really, so we've got H, K, R, all of them are not known, so we need 3 equations. So these are our first 2 equations. We need a third one. We haven't used the fact that the center is on this line. So if the center is on this line, H and K must satisfy the equation of the straight line. So that gives us equation number 3. Now notice that even though equation 1 and 2 look complicated because of these quadratic terms, if we subtract, all these three terms are going to fall away. So 1 minus 2, then we've got this equation, and then 3 and 4 now can be solved simultaneously. If you do that, you must find h is -3 and k is 1, and then we can now write the equation of the circle.